Okay, so let's start today's lecture. Okay, so during last lecture, we have been discussing the solutions. Okay, so how to find solutions of higher order non-homogeneous equations. Okay, so that's we talked about higher order. Okay, so higher order non-homogeneous equations. Okay, so higher order non-homogeneous equations. So the basic, homogeneous and non-homogeneous equations. Okay, so the basic idea is that if you have constant coefficient an yn's derivative plus an minus 1 yn minus 1's derivative. Okay, so plus a1 of y prime plus a0 of y is equal to b of t, right? So let's say, sorry. So yeah, b of t. So we're going to first work with the equation where b is 0, so that if it is 0, then you're going to consider r to the power of n plus an minus 1, r to the power of n minus 1 plus dot 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 plus a1r plus a0 is 0. You're solving for those r's, right? So, and based on the r, we consider three cases, right? So r as real, right? So, and is non-repeated root. If it is not real and non-repeated, you're going to consider ys of t is equal to e to the power r of t, right? So, and ri and j, let's say, is equal to lambda plus I times mu, the complex, a complex conjugate roots. Then the yi of t is equal to e to the power lambda t of cosinuses of mu t, and yj of t is equal to e to the power lambda t sinuses of mu t. Right, so that's kind of going to be the situation where you are going to have the complex roots. Okay, so you're going to have the complex roots. Now, with that at hand, there's also a situation where you have repeated roots. Right, so you have repeatedness in the roots. In that case, okay, so right, so repeated roots, you're going to use the so-called golden principle, right? So that we have been showing you before, that insert t's, right? So you insert t's until you reach satisfactory number of solutions. Okay. So and then we talked about this. Let's say this is a high order homogeneous equation. Okay. So this is homogeneous. And then what happens to non-homogeneous equation? Okay. So there's a higher order. Okay. So non-homogeneous equation. Right, so higher order non-homogeneous equation. If you want to consider non-homogeneous equation, then you're going to say that yn's derivative plus dot 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 plus a1 of y prime plus a0 of y is equal to b of t. You're going to look at the b of t, right? So depending on the right hand side, let me use g of t. Okay, so depending on the right hand side, you're going to consider g of t is equal to e power alpha t, or maybe cosine t of sine t, right, or polynomial, right? So a n t to the power of, let's say, a m t to the power of m plus a1 t plus a0 polynomial, or any combination of these two. And then you're going to try, like, based on our idea, right? So it's maybe it's a e power alpha t, and then it's this one is like a cosinuses of t plus b times sinuses of, let's say, beta of t. There's a beta of t, right? So cosine beta t, sine beta t. And then this is going to try a polynomial of the same order. Okay, so polynomial of the same order. So these are ideas that we might use in the theory of non-homogeneous equations. Okay, so therefore we've been trying several examples, right? So we've been trying several examples in last lecture just to show you how everything works out, right? So now let me start today's lecture by trying two more exercises, and just to show you that sometimes this calculation involving non-homogeneous, the calculation involving finding the particular solution for non-homogeneous equations, sometimes the calculations can be rather complicated. Okay, so the calculations can be rather tedious and complicated, and sometimes not so satisfactory. Okay, so let me try this example. Okay, so here it says that can you find a general solution of this equation? Okay, so let me take it. Okay, so we want to find a general solution of this equation. Okay, so let's continue from here. Okay, so just one moment. Okay, so we want to find a solution of this equation. So how are we going to do that? Well, you should start from the complementary, right? So let's say complementary equation, right? So you should start from the complementary equation is yc cubic derivative minus 3 times yc second derivative plus 3 times yc prime minus yc is equal to 0. So that's the complementary equation. With the complementary equation given, you want to try characteristic equation, right? So you want to try characteristic equation r cubed minus 3r squared plus 3r minus 1 is equal to 0. And as we said last time, in order to find solutions, right? So that's what we discussed in last lecture. In order to find solutions, you should have been trying to kind of do the grouping, right? So you should try to do grouping in order to find the solutions. So in that case, you want to group the first and the last one. So r cubic minus 1, and then it's minus 3 times r squared plus 3 times r is equal to 0. Then what happens here is that you're able to decompose it into r squared plus this one, and minus this 3 times r multiplied by r minus 1 is 0. So you factor out r minus 1 out. That's going to be r squared plus r plus 1 minus 3 times r. So that's going to be r minus 1 of r squared minus 2r plus 1. So that's r minus 1 cubic derivative is 0, because this is actually r minus 1 squared. Is a good family, right? So this is actually the example that we have been talking about in our last lecture, right? So this is just a repetition of that example, just to show you that grouping is sometimes a very important technique. Okay, so as long as you have this, it means that all the roots are 1. So that means r1 is equal to r2 is equal to r3 is equal to 1. So in that case, you want to find the complementary solution, right? So I say the complementary solution, you have to say that y of t, yc of t is equal to c1 e to the power of t. And then you're lacking solution. So c2t times e to the power of t plus c3t squared e to the power of t. So that's going to be the complementary solution. Is that good, family? Okay, so that's going to be the complementary solution. Now you want to find a particular solution of the original equation. So that means, I mean, you can see that the point here is that you have some problems with this one, right? So you have some problem with this one. So because the complementary solution is c1 e to the power of t, you have c2t times e to the power of t, and you have c3t squared e to the power of t. So then you're going to try a particular solution, right? So then you're going to meet the golden principle again. So because if you try y of t, let's say it's equal to a e to the power of t, then it agrees with part of the complementary solution. Remember, in the non-homogeneous systems, when we talk about method of undetermined coefficients, we will say that you do not want to kind of agree with any part of the complementary solution, because as long as you have the complementary solution, your equation is going to give you 0, right? So that's it's not going to give you much, right? So if you put this this is indeed a complementary solution where C2 and C3 are 0. And if you put this capital Y on the left-hand side of this original equation, then the right-hand side is going to be 0. And so that's not going to be anything. And why is that the case? Because you agree with the complementary solution. So you should use the golden principle to avoid complementary solution. That's why you want to multiply by t. But when you multiply by t, you still agree with the complementary solution, because the complementary solution has t e power t. So you don't want to e power t. And then as the t square, again, is not working. So you should at least try t cubic. So that's why we say do not hesitate to insert t's in the solution, right? So that's you insert pretty much enough number of t's. Is that good, family? Okay. So as long as you have that particular solution, you want to start to try. Okay, so you want to try y of t is equal to a e. So let's say as long as you want to try such a kind of particular solution, then you want to have the scenario that capital Y of t is equal to a t cubic e to the power of t, right? So therefore, how many derivatives you should take? Well, the original equation is up to the third order derivative. So you have to first take a first derivative. That's going to be 3 times a t squared e to the power of t plus a t cubic e to the power of t. So that's going to be y prime. And then you want to try y double prime of t is equal to 6 times at, right? So of e to the power of t plus 3 times at squared e to the power of t plus 3 times at squared e to the power of t plus, okay, so that's I'm taking derivatives here. And then there's the at cubic e to the power of t. So this all this calculation, the whole calculation is based on the product formula that we learned in calculus. Okay, so it's based on the product formula that we learned in calculus. But because we're using the product formula, the calculation sometimes can be pretty tedious, right? So pretty complicated and tedious. Okay, so that's going to be the scenario. Okay, so that's going to be the scenario. Now, as long as you have this, you have to keep taking derivatives. So let's first collect terms. So this is 6 times at e to the power of t plus 6 times at squared e to the power of t plus at cubed e to the power of t. Okay, and then therefore you have to take third derivative. So third derivative of t. So you're going to see that this is 6 times a e power t plus 6 times a t e power t, right? So and plus you take derivative here is 12 times a t e power t plus 6 times a t squared e power t, right? And then plus you take derivative here, so 6 times a t squared e power t plus a t cubed e power t. So you have all these things. Therefore, if you collect those terms, it's 6 times a e power t. There's a 6a, 12a, so that's 18 times a t times e power t. Plus here is a t squared is 9 times a times t squared e power t, and then plus a t cubic e power t. So that's kind of the calculation sometimes can be rather tedious and complicated. Okay, so that's calculation can be long. Okay, so it can be pretty long. So that's why I want to show you how this calculation is being done. Okay, so how this calculation is being done. So now you have all these derivatives. You want to just calculate this, right? So you just want to calculate this. So y cubic minus 3y second derivative plus 3y prime minus y. Okay, so we want to calculate capital Y cubic, right? So minus 3 times y second derivative, right? So and then it's going to be plus, right? So it's going to be just a moment, plus 3 times y prime. Okay, so 3 times y prime, and then it's going to be minus of y, right? So the whole thing you want to calculate it. So that means you just want to kind of put all these formulas there. So 6a e power t plus 18 times a t e power t plus 9 times a t squared e power t plus a t cubic e power t, right? So you have this one. Now minus 3 times y second derivative. So that's going to be 3 times the 6at e power t plus 6at squared e power t, and then plus at cubic e power t. So that's going to be this second derivative. Now first derivative is plus 3 times y prime is 3at squared e power t plus at cubic e power t, right? You have this. And then it's minus y is at cubic e power t. So let me just put it here. Okay, so at cubic e power t. So you have all these things, right? So then you just have to deal with this. I mean, this whole. Okay, so let me use red ink. Okay, so this whole thing, right? So it's they are kind of looking very very stunning, right? So it's so many terms you have to deal with them. So very important thing in calculation. So this lecture, we're not talking about any new methodology, but I'm just emphasizing the calculation details, because this is going to this is going to be what you are going to see on an exam, right? So I mean, our class is not just okay. So it is not just about methodology, but it is also about what? Well, it is also about how to make good calculations. Okay, so even if you know the method, it is not enough for you to be successful in the exams of this class, because you have to do calculations, and the devils are in the details. So I would say devils. Okay, so devils are in the details. Right, so the details can be hard to work out. Okay, so devils are the details. So, and in order to deal with those details, it doesn't just mean that hard work and sweating is enough, but you have to know the method, right? So you have to know the key, how to work things out. Okay, and what is the key here? Well, the key here is to group. Okay, so how do you group? Well, before you group, you have to observe what types of terms are there. For example, you have this t e power t term, and then you have the t, so you can collect with respect to the orders of t. So for example, you have the t square e power t term. Okay, so the reason why I don't use color ink is because you don't have color ink on the exam, so you have to kind of draw a picture. So that you have to draw those different types of lines. So that's what I'm showing you here. Okay, so you can see you can collect t square e power t, right? So there are t square. And then you can collect the t cubic e power t, right? So t cubic e power t, t cubic e power t, t cubic e power. So you group according to the powers of t. And you should be careful with the coefficients, right? So let me start with the 6 times a e power t, right? So 6 times a e power t. And then you can see that you have t e power t, so that's going to be 18 times a, okay? So something multiplied by t e power t, right? So you have several terms. And what the next term? Well, it's a 3 minus 6a, so 3 minus 6 times a. That's going to be your second term. What about t square e power t, right? So there's going to be some terms, t square e power t. And what are these terms? Well, that's going to be 9 times a, right? So, and then it's going to be minus 3, okay, so minus 3 times 6 times 8, right? So, and then t square is plus 3 times 3 times 8, right? So it's going to be something like this. And then it's going to be, the next term is t cubic e power t. And what are these terms? Well, there is an a, right? So there is an a. And then there's a minus 3 times a, right? So 3 times a. And then it's plus 3 times 8t cubic. And then it's minus 8. So you have all these terms. And then you do some calculation. You see 3 multiplied by 6 is 18. So you have actually 0 here. And this is 9 plus 9 is 18 minus 18. So there's 0 here. This a minus a, 3a minus 3a. So it's again 0 here. So you have nothing about this. So it's just 6a e power of t. And this will, according to the non-homogeneous equation, is times 4 times e power of t, from which you can see that 6 times a is 4. So a is 2 over 3. Is that good, family? Okay, so that's you have this. If you don't know how to group terms, then you're going to run really in a mess when you try to calculate this, right? So you will run in a real mess, right? You will run in a real mess. But if not, then you're going to see that you're going to have a pretty nice scenario to calculate the a. Now the question is, why all these terms are 0? Can you see why? Well, the reason is very simple, because the right-hand side, right? So the original right-hand side is something like this. It doesn't have this t e power t, t cubic e power t, t square e power t, and t cubic. They don't have this. If they don't have this, it means that your coefficient, even with the coefficients, you're not going to have all these terms. So smart, I mean the real confident, I should not say smart, because maybe you made errors in the calculation. So when say if you're very confident with your calculation and you're smart, you won't do all these calculations. You will just collect the 6a e power t, and let it be 4 times e power. So this is really a way when you don't have enough time on the exam, you can just you can just gamble on your fortune, right? So that's one way to do it faster. But the problem is that sometimes the people make errors in this calculation so that they won't end up in the right result. In that case, it's better to double check, to collect these terms and see they're really zero in order to obtain our results. Okay, so that's kind of, these are kind of remarks in the calculation, because I'm not just teaching you methodology, I have to teach you how to do the details. Okay, so that's because you're going to really face this type of problems on your exam. So with this all this account, you can see that the particular solution is found, right? So let's say the particular solution is found to be y of t is equal to 2 over 3. We tried t cubic e power of t. So that's going to be the particular solution. As long as you have the particular solution, you also have the general solution. You can just combine them, right? So here we know that the coefficient a is equal to 2 over 3. So therefore, the general solution, right? So the general solution is going to be y of t is equal to c1 e power t plus c2 t times e power t plus c3 t cubic t squared e power t plus 2 over 3 t cubic e power t. That's going to be your general solution. Is that good for everybody? Okay, so that's kind of very simple exercise. Okay, very simple exercise. Okay, so now I have about, let me take about 20 minutes to practice a much more sophisticated problem. Okay, so just to show you that sometimes the calculations can be really complicated. Okay, so they can be really complicated. Okay, so and but during this procedure, we're going to see more, I would say, devils in the details. Okay, so here we want to find the general solution of this equation. Okay, so let me take this equation. Okay, so we want to find a general solution of this equation. Okay, so this equation is, okay, so you want to find a general solution of this equation. So how do we find a general solution of this equation, right? So in order to find a general solution of this equation, we have to kind of first try, let's say, the complementary equation, right? So that means the complementary equation. Right, so as before, the complementary equation is yc, the fourth derivative, plus 2 times yc, the second derivative, plus yc is equal to 0. That's going to be complementary. Therefore, you have the characteristic equation, right? So the characteristic equation is going to be t. Okay, so it's going to be r to the power 4, right? So it's going to be r to the power 4 plus 2 times r squared plus 1 is equal to 0. Now you solve this characteristic equation is r squared plus 1. Squared is equal to 0. So you see R1 is equal to I, right? So R2 is equal to, so you just want minus I. And maybe R3 is actually equal to R1 is equal to I. R4 is equal to R2 is equal to minus I. You have duplicated rules, okay, repeated rules. So therefore, the complementary solution, okay, so, right, so the complementary solution is going to be yc of t is going to be c1 cosinuses of t plus c2 sinuses of t, because you have I and minus I. But for the repeated ones, you just want to insert the t's, t cosine t plus c4 t sine t. So you're going to insert some t's. Is that good for everybody? Okay, so you have, this is the complementary solution. So therefore, you want to try a particular solution, right? So you want to try a particular solution. So that means you want to try a particular solution, right? So you want to try a particular solution. So what will be the particular solution look like? Well, it's going to be a capital Y of t, right? So, but your right-hand side is sine and cosine. So according to our principle for finding particular solutions for method of undetermined coefficients, you're going to just try a cosinuses of t plus b times sinuses of t. So that's what you're going to try. Okay, so a cosine t plus b times sinuses of t. So that's kind of let me try. Let me use. Okay, so without loss of generality, in order to agree with my lecture notes, let me use a. Okay, so let me use a sine t. Okay, so I mean, it's the same. It's just replacing the sine by cosine, cosine by sine. So let me say a sine t plus b times cosinuses of t. So that's going to be like the general principle. Okay, so that's going to be like the general principle. Okay, so that's going to be like the general principle of finding this particular solution. However, you can see that situation here is not so simple, right? So because why? Because the situation here is going to involve, okay, so it is going to involve, again, it's going to involve the golden principle, because the sine t and cosine t already agrees with part of the complementary solution. And so therefore you have to insert t's, right? So you maybe at least insert one t in order to avoid this particular complementary solution. But then when you insert t's, you're still not okay, because you already have the t's there, so you want to try t squared. So that's going to be what happens to your particular solution. Is that good, family? Situation is not so simple because you have to use the golden principle. Is that good, family? Okay, so golden principle. Now with that particular solution in hand, you have to kind of we started to do some tedious calculation, because you're going to have a t square of sinuses of t plus bt square of the cosinuses of t. You get this function, right? So this function is what you're going to try by your I mean, it does not overlap with part of the complementary solution. It's going to be your particular solution. So then you have to take derivatives. Is that good, family? Okay. So you take derivative. How many derivatives you take? Well, up to the fourth derivative. So this is the most tedious part of the work that you have to go through. You have to calculate. Okay. So, but let's do it. Okay. So this is this part of the mathematics. Is kind of mostly by patience. Okay, so you have to be patient enough to go through the very tedious calculations, but you also have to be okay. So, but you also have to be smart from places to places. Okay, so you kind of have to kind of be smart in order to avoid complications in your calculations. Okay, so let me try to show you what it goes. Okay, so as I said, this lecture is trying to show you the details, okay, because this is what you're going to encounter on your exams. Okay, so you have to kind of fight against these details. Okay, so let's say what is y prime of t. Okay, so well, in order to take derivative, you have to again use the product rule, and therefore let's say it is a t squared, derivative is 2at of sinuses of t, plus a t squared sine t, derivative is cosine t, and then plus bt squared is the 2bt of cosinuses of t, plus bt squared, cosine t derivative is sine t, but the cosine t derivative is there should be a minus sign in front of the sine t. That's y prime. But then the smartness comes out, namely you have to look at those terms. You see, you're going to have t sine t, t cosine t, t squared cosine t, t squared sine t. So therefore, if you take another derivative, you're going to see this, you keep taking those derivatives. So that's 2a of sine t plus 2at of cosine t, right? So cosine t plus 2at of cosine t. This is this one derivative plus at squared cosine t derivative is sine t with a minus sign. So that's a minus at squared sine t. Then you have to take derivatives of this one. So that's a 2b cosine t minus 2bt sine t, and then minus the 2bt sine t minus the bt squared cosine t. So you're going to have something like this. Okay, so as long as you have all this, then it means that this is 2a of sine t, and then you have 2at cosine t, 2at cosine t. So that's going to be 4at cosine t, and then you have t squared of sine t. So let me say a t squared of sine t, and then you have 2b cosine t, right? So let's say 2b of cosine t, and then 2bt sine t, 2bt sine t is a 4bt of sine t minus bt squared of cosine t. So that's going to be, this is kind of a rather sophisticated formula. Okay, so it's rather sophisticated form. Let me compare and make sure I'm correct. So you have to make sure that you're correct in each of the intermediate steps in order to avoid errors. Okay, so because when you these errors occur in chains, right? So if you obtain one error somewhere, then you're going to propagate. Okay, so this error is going to propagate to more errors in the future. So that's not what you want to see in this problem. So this is y7 derivative. So how far are we? Well, we have to take third and fourth derivative also. So that's going to be quite sophisticated, and but you have to kind of do it. Okay, so that's going to kind of really takes time and takes your patience. Okay, so that takes time and your patience, but you have to kind of do it carefully. Okay, so in order to reach the goal. Okay, so that's to overcome those problems in the details. Okay, so let's continue. Okay, so we want to take a third derivative of t. So third derivative of t, you have to start with this one. So that's going to be 2a of sine t derivatives cosine t, plus this one is going to be 4 times a cosine t minus 4at sine t, right? So, and then it's a minus, you have this derivative is 2at sine t minus the at squared cosine t, right? So, and then plus 2b, there's a cosine t derivative. So cosine t derivative is sine t, but don't forget minus sine. So if you make errors in even one of the signs, you're not going to come out. Okay, so then it's minus 4b t derivative. So it's sine t. It's minus 4bt of cosine t, right? So and then minus this one, right? So this was going to be 2bt of cosine t minus bt squared of sine t. Cosine t derivative is minus sine t, so that's going to be plus sine. Is a good family? You have all these terms. Now you want to start a collection, right? So you want a collection. So 2a, 4a is 6 times a of cosine t, right? So, and then it's at sine t, at sine t. So that's going to be 6 times at of the sine t, right? So, and then it's minus the at squared of the cosine t. And then it's 2b sine t, 4b sine t minus 6 times b of the sine t. And then 4bt cosine, 2bt cosine, so 6 times bt of the cosine t plus the bt squared of the sine t. So that's going to be the third derivative of y. Is that good, family? Okay, so that's going to be the third derivative of y. And let me double check. Okay, so 6a cosine t. Okay, so 6at sine t, right? So and at squared cosine t. Okay, so 6b sine t and 6bt cosine t, right? So and then bt squared sine t. So that's going to be the third derivative. And then you're going to do the fourth derivative, right? So this is not enough, but you have to keep doing everything until you reach the fourth derivative. Okay. So when you've reached the fourth derivative, what you're going to see, well, you're going to see that this is fourth derivative. You keep taking derivative. So minus 6 times a of the sine t, right? So and then it's a minus. You have another 6 times a of the sine t, and then cosine t. So that's going to be minus 6 times at of the cosine t. So that's going to be the situation. And then you have the derivative here. So that's minus 2 times at of the cosine t. And then minus a of the t squared. Cosine t derivative is sine t, but you have a minus sign. So it's going to be plus. Is that good for everybody? Okay, so that's so far we're here. Okay, so do not lose. Okay, so get lost in this jungle. Okay, so now you start this one. So that's minus 6 times b of the cosine t. Okay, so minus 6 times b of the cosine t, and then minus 6 times the bt cosine t derivative is going to be sine t, right? So but you have a minus sign. So there's a plus here, right? So plus here. And then we now reach this one, right? So that's going to be plus 2bt of the sine t. Okay, so plus bt squared of the cosine of t. Okay, so that's going to be the scenario. So now you collect the terms. You're going to see that this is minus 12 times a of the sine t, right? So, and then minus 8 times a of the t times cosine t, right? So, and then plus a of the t square of sine t, right? T square sine t. And then you have this minus 6 times b of the cosine t minus 6 times b of the cosine t. So therefore, you are going to minus 12 times b of the cosine t, and then it's 6bt sine t, 2bt sine t, so that 8 times bt of the sine t plus bt square of the cosine t. Is that good for everybody? Okay, so that's going to be the fourth derivative. If you look at this formula, okay, so 12a, 8 times a, okay, so at squared, and then 12 times b, 8bt and bt squared. So that's going to be indeed the fourth derivative. So that's kind of this whole calculation is going to give you from the zeroth derivative to the fourth derivative. But this is not enough yet, but because you have to calculate the calculation of this one, right? So the left-hand side of this equation. Therefore, you want to see then, okay, so then you're going to see y fourth derivative, right? So the fourth derivative plus 2 times second derivative, okay, so, and then plus the y, right? So plus the second derivative plus y is going to be what? Well, you have to do the fourth derivative first, right? So here you see on the exams, you're not like me, you cannot just kind of cut these formulas, but you have to copy them, right? So I would like to kind of try it here. Okay, so just to show you what's actually on the exam. So you have to copy them, and when you copy the formulas, do not make errors. Okay, so 12 times a of sinuses of t, right? So, and then minus 8 times at of the cosinuses of t, right? So, and plus at square of the sinuses of t, right? So at square, and then it's minus 12 times b of the cosinuses of t, right? Cosinuses of t plus 8. Okay, so let me write it more tidy. Okay, so let me take 12 times b of the cosinuses of t, right? 12 times b of cosine t plus 8 times bt. Okay, so 8 times bt of the sinuses of t, and then plus bt square. Okay, so bt square multiplied by cosinuses of t. So you're going to have this, right? So that's the fourth derivative. Then you're going to see that you have to do 2 times the second derivative. The second derivative is kind of have all these terms, right? So 2a times the sine t, 2a times sine t, okay? So, and then it's going to be 4at cosine t, okay? So plus 4at cosinuses of t. Then it's going to be at square sine t, okay? So at square of the sine t, okay? So, and then it's going to be 2b cosine t, okay? So that's going to be 2b of the cosine t, okay? So 2b cosine t. And then there's a 4bt sine t, okay? So that's going to be 4bt sine t, right? So 4bt sine t. And then it's going to be, okay, so bt square cosine t. So that's going to be bt square of the cosine t. Oh, this whole thing is multiplied by 2, right? So this whole thing is multiplied by 2. And then it's plus y, okay? So y is simple. It's where you start the story is at square, okay? So at square of the cosine sine t plus bt square of the cosine t, right? So at square of the sine t plus bt square of the cosine t. So that's going to be the scenario, right? So that's going to be a scenario. Now, as long as you have this whole scenario, you can see that I can collect those terms, right? So I collect those terms. So how do you collect these terms? Well, first of all, according to the original equation, okay, so original equation, it is 3 sine t minus 5 cosine t, right? So 3 sine t minus 5 cosine t. So what does this mean? Well, if you look at this side, okay, so you look at this part, you have sine t and cosine t, then you're going to have t cosine t, right? So t cosine t, right? So, and then you're going to have t sine t. You're going to have t sine t. Is that good, family? Right? And then let's say you're going to have t square sine t. right? So you have t squared sine t, you have the t squared sine t, right? So t squared sine t, and then here is again t squared sine t, and then you have the t squared cosine t. Okay, so let me use this. Okay, t squared cosine t, and then you have this term is t squared cosine t, and you have this term is t squared cosine t. Is that good, family? And then you have this sine t, cosine t, sine t, cosine t. Is that good? So according to the principle that we've been explaining in the previous previous problem, this has to be 0, right? So I mean, if you're very confident with your calculations, you don't see anything like this. I mean, they're not going to enter because they don't enter the real right-hand side. They don't enter the coefficient related real right-hand side. They're going to be zeros. And that's going to be nice because then you're going to see that this is 12 times a. This is what? This is 4 times a. So that's going to be minus 8 times a of the sine t, right? So what about cosine t? Well, same thing, right? So that's going to be minus 8 times b of the cosine t. That's going to be enough. Is that good, family? Okay. The rest of the terms are 0. If you know that your calculation, you never made any mistakes. If you kind of guaranteed that you don't make mistakes, you already have this right? So you won't have any problems with this. Okay, any problem with this. So with that hand, it's going to see that minus 8 times a is equal to 3, and 8 times b is going to be equal to 5. So that's going to give you a is equal to minus 3 over 8, and b is equal to 5 over 8. And that's going to be good. Is a good family. However, this calculation is, you're not, I mean, sometimes you're confident. Now, there are two reasons that why you want to do this. First thing is that you're very confident, like me, right? So, and the second reason maybe is on an exam, you don't have enough time to calculate everything about this. They are too complicated. Then you want to kind of bet your fortune, right? So you make a bet. You just see that maybe I am right so far. So this is just like the fastest way, shortest way to arrive at the goal. But if you're not so confident, you have to carefully do the calculations, right? So if you do the calculations, you have to be faithful. Okay, so that's going to be what? Well, that's going to be minus times 8 times a. If you want t cosine t, then it's 2 multiplied by 4. So that's 2 multiplied by 4 times a multiplied by t cosine t. So indeed it is 0, right? So you won't have this. What about sine t? Well, they're going to be plus times 8 times b, right? So t sine t. And then there's a minus 2 times 4 of the b of the t sine t, right? So t sine t. So that's going to be the scenario. Is that right? So t sine t. Now you're going to have t squared, right? So t squared. So let's say plus some coefficient multiplied by t squared sine t. So you want to collect this star terms. So that's going to be a, right? So there's 1a. And then it's a minus 2 times a is a t squared sine t. And then it's a plus a. So that's going to be, again, it's going to be 0. This is going to be 0, right? So, and then it's the last term is going to be t squared cosinuses of t. And cosinus of t, you're going to have a b here. And then it's a 2. Remember, there is a 2. Don't forget about this, to multiply by b. So minus 2 times b. And then plus 1 times b. So again, you're going to have 0. So that's kind of, it's indeed the case. It is indeed the case. Is that good, family? Okay, so that's you have a and a b. So as long as you have a and a b, so you're going to see that you can come back. Okay, so you can come back to this particular solution that you're going to replace the a and the b by what you have calculated. Right? A is minus 3 over 8. Okay, so minus 3 over 8, and b is equal to 5 over 8. Right? So b is equal to 5 over 8. Now, as long as you have this, you can see that the general solution, right? So the general solution is going to be y of t is equal to c1 of the cosinuses of t plus c2 of the sinuses of t plus c3 of the t times cosinuses of t plus c4 of the t times sinuses of t minus 3 over 8 of the t square of the sine t plus 5 over 8 of the t square of the cosine t. So that's going to be your general solution. Is that good, Faber? Okay, so you can see that this whole problem takes us a lot of time because the calculation is just so complicated, right? So the calculation is just so complicated that this whole thing takes a lot of time for our lecture, but this is actually necessary because I just want to show you. Okay, so the reason why I took this particular two problems today is that I would like to show you that sometimes the calculations can be very complicated. And by viewing, okay, so I mean, you see, I didn't use any kind of, I didn't jump any kind of steps, because by viewing how I do these problems, I hope you will have better understanding of what is happening. Okay, so what is happening on your real exams when you're really trying to solve a problem, what kind of detailed devils you're going to see in your calculation. It's not as simple as you just you just sit there. Maybe you're just lying there, right? So viewing the online lecture, and it's not going to be the case. Okay, so you have to really do the tough work. Okay, so that's what I want to say for higher order equations. Okay, so let me make a small review here. Okay, so what happened here is that if you have like this kind of equation, right? So in derivative, an minus 1, let's say n minus 1's derivative, plus dot 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 plus a1 of y, okay, y prime, plus a0 of y, let's say is equal to 0, right? So the reason why you can relate this equation to an, let's say the characteristic equation, so that r to the power of n plus an minus 1, r to the power of n minus 1 plus dot 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 plus a1 of r plus a0 is equal to 0. You want to connect it to this one is because you have kind of identified, okay, so you have identified y to be equal to e to the power of rt. So that's what you want to try. Is that good, family? Right? So what you happen here is that there is actually a relation between the y. Okay, so this is the y equation. This is the r equation. They are connected with each other by this very simple transformation principle that y is equal to e to the power rt. So which means that from the y, you can calculate the r. So r is actually equal to the logarithm of y, right? So then it's divided by t. Is that good, family? Right? So let's say you have the kind of the mutual relations between y and r. So basically, in order to solve this differential equation, you're kind of solving this algebraic equation on the r side. Is that good, family? Okay, so on the r side. So that's kind of the real idea that's behind what we have so far, because we started everything from this transformation. Now we say if you transform the r, you see not only such equations, but also like e power lambda t cosinuses of sinuses or things like that. Is that good, family? Okay, so maybe use the t golden principles or things like that. But this is the reason why we started from the complementary, and then from the complementary, you know that you can find particular solutions, right? So this is what we have been doing so far. You try particular solutions, y prime plus a0 of y, let's say equal to p of t. You try particular solution, capital Y. And then you say that y of t, the general solution, is yc of t, right? So let's say this is the yc equation, right? So plus the capital Y of t. So, and that's going to be your what we have been learning so far. So you can see that if you want to have better theory about differential equations, you should come back to this transformation, y is equal to e power rt. So this is the key, because you don't know how to solve differential equation, you know how to solve algebraic equations. Is that good, family? Okay, so this will be the starting point of our next chapter, which we're going to extend these transformations to a kind of a new type of transformations, but have the same essence as this one. We're going to call them Laplace transforms. Okay, so we're going to call them Laplace transforms. Okay, so that's going to be kind of a better understanding of our future lectures. Okay, so that's what I want to say for today's lecture. Let's stop here, and I'll come back to the next lecture and keep my discussion.